Hi everyone, today we are going to practice converting rectangular equations into polar equations and vice versa. If you don't have these conversions written down already, I would copy them down. And if not, honestly, I have them on every slide anyway. So we're going to do 3 conversions from rectangular to polar, and then we're going to do 3 the opposite direction, okay? So we're going to start off with converting rectangular equations to polar equations. This means that you're going to be given an equation that has x's and or y's, or both, and we want to manipulate this equation by using the conversions to get r's and betas, okay? And if possible, solve for your r. So, the first example is convert x squared plus y squared equals 16 to polar form. Okay, so we're starting off with x's and y's. We're going to look at our conversions, and which one do you think we can use? Like, there's one that looks oddly similar. It is the last one. Okay, so what I'm going to do is I'm going to put it right under, and things happen to match up, right? Like the x squareds are the same, the y squareds. That just means that what's left over is r squared has to equal 16. And since I'm trying to solve for r, you're just going to square root both sides. So I get r equals 4. What does that mean? What did we just do? We turned the rectangular equation x squared plus y squared equals 16 into the polar equation r equals 4. Started off with x's and y's, used that third equation to manipulate it, and in the end just got an r. Okay, so I kind of always want you to ask yourself that question. Did I start off with x's and y's? Did I successfully manipulate to only get r's and betas? Okay, we don't have a beta. Yes, that is correct. You don't need a beta, but for sure you just can't have x's and y's. So the fact that we at least have an r, that's all that matters. Okay? All right, the next equation is going to be convert y equals 3 to polar form. So I'm going to look at my conversions and figure out which one do I want to use. Probably going to be the second equation because we have y equals 3, and that one says if you have a y, this is how you can change it into polar. Okay, so I'm going to use that, and this is how we're going to do it. We were given y equals 3, right? Like, that's what we started off with. We're using the conversion y equals r sine of beta. So I'm going to substitute what I was given, which is y equals 3. I'm going to substitute that in, so I will eventually get 3 equals r sine of beta. Okay? Or r sine of beta equals 3. Alright, and then we're going to solve for y when possible, or r when possible, so I'm going to divide both sides by sine of beta. And we can actually simplify this even further. So we have an identity. It's kind of a hidden identity. Remember, there's always times an imaginary 1. So this is the same thing as 3 times 1 divided by sine of beta. Does anyone remember what 1 divided by sine of beta is? Because that is an identity. Well, if you don't have it, it's in your notes. 1 over sine of beta is the same thing as cosecant of beta. So this turns into r equals 3 cosecant of beta. Did we get rid of our x's and y's? Well, we were only given a y to begin with, but we got rid of it, and we successfully got an r, and this time we got a beta, so we're good. This last one, yeah, it's a bit more difficult, but we're just going to do the same thing that we did. I'm going to look at the equation. Which conversion method do you think we should use? I'm going to take a wild guess. It looks kind of similar to this last one. Okay, but it's not quite the exact same. Why? Because we have x minus 3 squared and y plus 3 squared. What does that mean? You are going to have to square each binomial. And when you do that, it's going to be x minus 3 times x minus 3. So you will have to distribute, okay? So once you do all that and you distribute correctly, we get x squared minus 6x plus 9 plus y squared plus 6y plus 9 equals 18. Okay, I'm going to start combining like terms. So on my left side, I have a plus 9 and a plus 9. So that means that I have 18 on the left side and 18 on the right side. I can get rid of it, which means I am left with x squared plus y squared minus 6x plus 6y equals 0. Okay. We simplified it, but we still have x's and y's, right? So here's what we're going to do now. We are going to substitute. Again, I would say we didn't really substitute in the first place. We're going to substitute now. So we're looking at our conversion equations at the top right corner. And what do I notice on the equation that I have? I notice that I have x squared plus y squared. Oh, and look. X squared plus y squared equals what? R squared. So that means that I can replace x squared plus y squared with r squared. Okay? Then, that also means that I can replace this x right here with r cosine of beta. And I can replace this y with r sine of beta. Okay? Great. So I'm going to do that. And I get this, r squared minus 6r cosine of beta plus 6r sine of beta. Okay. Okay, now what can we do? We have 3 different terms. What do these terms all have in common? Ooh, they have an r in common. So I'm going to factor out an r from every single term. And when I do that, I get this. R times that equals 0, okay? And then I know that when I have factors, I'm going to set the factors equal to 0. And then I'm going to solve. So I get this. I get 2 possible answers. I get that r either equals 0 or r equals 6 cosine of beta minus 6 sine of beta. Okay, so we started off with the original equation. It looked similar to the third one, but we couldn't really do anything, so we simplified it first. We distributed, we combined like terms, and then we got to that, right? And then after that, then we started substituting. And in this example, we had to substitute 3 times, whereas the other one we only had to substitute like once, okay? But that's it. We started off with x's and y's. We manipulated it. We started substituting. And in the end, we were only left with r's and betas. Okay? Fantastic. All right, now we are going to convert polar equations to rectangular equations. So it's very similar. We are going to start off with r's and betas this time. And we want to manipulate it to get x's and y's. So convert r equals 4 to rectangular form. Okay, which conversion route do you think we should take? Probably this last one, the one that says if you square r, you will get x squared plus y squared. Okay, so when I square r, I get r squared equals 16. Substitute. Wow, x squared plus y squared equals 16. This is the rectangular equation to r equals 4. So what happened? We started off with an r. We plugged it into the bottom equation because it was straightforward. Like r just equaled a number, so I could have plugged it in. It didn't have any betas, right? And then after that, I just got the equation x squared plus y squared equals 16, which had x's and y's, which meant that I made it to the rectangular form. Okay, this next one right here, we have r equals 5 cosine of beta. So this one is different because I don't have r equals just a number. I have r equals cosine of beta. So let's try getting rid of that one first. And to do that, I'm going to use this first equation right here, meaning my cosine of beta, I'm going to get rid of that by substituting in x divided by r. Okay? So I get r equals 5 times x divided by r. Okay? What's the goal when converting to rectangular? I want x's and y's, right? So if I want x's, that means I'm going to multiply both sides by r to get x by itself, right? Yes. So when I do that, I get r squared equals 5x. Okay, that's great. We're almost there, but I still have an r. So my question is how do I get rid of that r? Or r squared? Well, if I look at my conversion equations again, this bottom one right here turns an r squared into x squared plus y squareds, right? So I'm going to do that. I'm going to substitute this 5x into this r squared right here, and then I will have the x squared plus y squared. So I get x squared plus y squared equals 5x, and that is the rectangular form. Don't have any r's, don't have any betas. We are good. This next one, I'm going to convert r equals 2 cosecant of beta to rectangular form. So it's very similar to the one that we did, but I don't know what the equivalent of cosine of beta is. It's not in my 4 equations. Well, what do I know cosecant of beta is? It was definitely on the other slide. We said that cosecant of beta was 1 over sine. Whoa. That's wrong. Cosecant of beta was 1 over sine of beta, but let's generalize it even more because that's specifically on the unit circle. This is going to be r over y. Okay? All right. So, we have that. We're going to substitute it in. I get r equals 3 times r divided by y. Okay, again, I want to get rid of my r's and only keep my y's, right? So I'm going to multiply both sides by y, and when I do that, I get y times r equals 3 times r. Okay, I want to get y by itself, so I should divide both sides by r. When I do that, those cancel out, so I end up getting y equals 3. And this is the exact same thing. Yes, y equals 3 is the rectangular form. Got rid of my r, got rid of the beta. We're good. Oh, and we're done. I really hope these 6 practice problems helped you out. Yeah, thanks for watching.